Hello friends, we start with our next topic that is known as problem solving session, especially for OPAMPs. In my previous video, we have already seen the basic concepts of operational amplifier. Now we start with the problem solving session of operational amplifier, and we will see different type of problems which are coming under OPAMP and the techniques how we'll solve it to find out the current, voltage, load, whatever it is. Okay, so if still you have not subscribed, comment and like my channel, please do it. Please subscribe it, because once you subscribe it will be more easy for you to go through my all previous videos. Okay, so we start with our next problem. So this is our problem number 1. So friends, this is our problem number 1. In this problem it is given that the operational amplifier is ideal in nature. You have to find this value of V0. Basically you have to find the output value of V0. You have to find the value of V0. It is given that this OPAMP is ideal in nature. Okay, so whenever you will see that the OPAMP is ideal in nature, so two things you have to keep in your mind. No current will enter here. No current will enter here, and whatever the potential of these two nodes, say this node is A, this node is A, this node is B. So just keep in mind the value of VA and VB will be equal. Okay, and no current will flow here. So now by applying this concept, we have to find the value of V0. So how we will find the value of V0? So as I said, V and VB is equal, and you know VB, the value of potential VB is what? Basically 4 volt. You can say that the value of VB is what? It is 4 volt. So similarly you can say that the value of VA is what? It is also 4 volt. So this is our first thing, that we have find the potential of we have find the potential at node A. Okay, and that comes to be how much? 4 volt. Now always keep in mind, just apply a law of KCL and find the answer. So see, one current is coming here, and I will consider that current will go there itself. Okay, since no current will enter here, the same current will move here. So you can say that the potential at this VA, you can say that VA, and here is the potential is what? V0. So you can say VA minus V0 upon 2K. Okay, the current which is flowing here. And what is the current which is flowing here? This 1 milliampere. Yes, the same current is flowing here. So you can say that that is equal to 1 milliampere. Yes, you can say that the current which is flowing here between these two nodes, is what? The current, that is 1 milliampere which is flowing. So this is your current. So from here you can say that VA minus V0 is equal to 2. Kilo and milli will cancelled out. You know the value of VA, that is how much? It is 4 volts. So it is 4 minus of V0 is equal to 2. So you can say that the value of V comes to be how much? It is 2 volt. So this is your first answer. Okay, this is your first answer for V0. So in this way we have find the value of V0. Okay, we'll see the next problem. Now friends, this is your next problem. In this problem again you have to find the value of V0. You have to find the value of V0. Now this is one important problem. Here you have to understand the concept and how we are going to solve this network. Okay, now please keep in mind what will happen as per our concept of that is a virtual ground. As per our concept of virtual ground, we used to say if it is A and it is B, so you say VA and VB is equal. Yes, okay. As per the concept of virtual ground, your VA and VB is equal. So here this VA, the value of VA is what? Is 3 volt, and this is your value VB. Okay, but please keep in mind these two potential here V and VB is 3 volt, but don't think that this 1 volt will appear here. Sometimes you will create a confusion. So you can say that now from here to here, from this path to this path, you can apply one KVL. So what is the voltage here? Here the voltage is V0. So you can say that V0 plus of 1 minus of VB is equal to what? 0, or you can say V0 equal to VB minus of 1. What is the value of VB? It is 3 minus of 1. That comes to be how much? It is 2 volt. So this is the value of V0. Just keep in your mind. This is the value of V0. Okay. So this we have find the value of V0 as 2 volt. Now we move on with the next problem. Now friend, this is your next problem. In this problem you have to find the value of V0 and I0. Okay, in this problem you have to find the value of V0 and I0. Now please try to understand. This is your operational amplifier. Again, this is an ideal operational amplifier, and these are the connections of the resistance connected in this fashion. Now we will see how we solved it, how we are going to solve this and find the value of V0 and I0. So what we will do, you can say that this potential is what? Is V0. Yes, this potential is what? Is V0. So first of all we will find the value of V0. Okay, so now how you find the value of V0? Now please see, this is your 3 volt source and here is this combination. So can you find this voltage? This voltage, again you say it is VB, and this voltage, say this is A, this is B. So as per our concept of virtual ground, VA and VB is equal. But can you find the value of VB? Yes. How? Just by applying the voltage division rule. Why? Because this 3 volt will appear across this B node just by converting into their equivalent voltage division rule. So you can say that the value of VB is what? It is 3 into the potential which is across 10 ohm upon 5 plus 10. Yes. So that comes to be 3 into 10 upon, that is 15 or 30, or you can say it is 2 volt. So the value of VB is how much? It is 2 volt. So once you know the value of VB, so your value of VA is also what? 2 volt. So here the potential is what? 2 volt. What is the potential here? It is 2 volt. Now can you find the value of V0 just by applying KCL? As I said, no current will enter here. Just keep in your mind, no current will enter here. So by applying KVL, that is KCL at node A, we can find the value of V0. How? Please see. This potential is 3 volt. Okay, just keep in mind. So that comes to be, it is 2 minus of 3 divided by 2 kilo ohm, that is the current which is flowing here, plus of 2 minus of V0 divided by 8, that is equal to 0, the current which is flowing here. So this current and this current. So these two currents we have considered. Okay, so now can you find this value? Yes, it is minus 1 by 2 plus of, or you can what you will do, just multiplied by 8. So that comes to be 8 into minus 1 by 2 plus of 2 minus of V0 is equal to 0, or you can say V0 is equal to how much it is? Minus of 4 plus of 2, so that comes to be minus 2 volt. So this is the value of V0. This is the value of V0. Okay. So now as you know the value of V0, now how you find the value of I0? Now if you see here, this is your I0. Some current is flowing here, some current is flowing here. Okay, and this potential is what? Your V0. So you know the value of V0. Okay, it is connected to ground and it is connected to node A. So yes, you can easily find the value of I0. Okay. Okay. So for finding out the value of I0, I will apply KCL here. I will just apply KCL here at this node. Okay, at this node KCL. So now see how it is. It is V naught upon 4 the current flowing here, okay, minus of I naught the current which is coming towards the node, and V naught minus of 2 upon 8 is the current which is flowing here. Yes, this is our simple equation. Now just multiply it by 8 and find the answer. So that comes to be how much? Here I am solving it. So that comes to be twice of V naught, okay, minus of 8 I naught plus of V naught minus of 2 is equal to 0. So that comes to be 3 V naught minus of 2 is equal to 8 of I naught. Now what is the value of V naught? Please see. It is minus 2 volts. So 3 to 6 minus 6, or that comes to be minus 8 equal to 8 I naught. So from here you can say that the value of I naught is equal to minus 1 ampere. So this is your answer. Okay. So you got the value of V naught and you got the value of I naught. Okay. V naught is minus 2 volt. I naught is minus 1 ampere. This is one important problem. Okay. Just to understand how to solve it. Okay. Now friend, this is your next problem in which you have to find the value of Ix. You have to find the value of Ix. Okay, this current. So now see, this is your one node. Okay, this is your one node. So if I say this potential, if I say it is VA, and this potential if I say it is VB. So as per concept of virtual ground, VA and VB is equal. Okay, and no current will enter here. Just keep in mind, no current will enter here. So can you say that this Ix current is the current which is flowing here also? The same current. This current is also what? This current is also Ix. The same current. Why? Because since no current will enter here, so this Ix, it means it is coming from here. So you can say that Ix is the current which is flowing here also. Okay. Now to find the value of Ix, how you find this value? Okay, how you find this value? Now for finding out the value of Ix, the first thing is we must know this voltage. Let this voltage is V. If we know this voltage, or you can say if you know this voltage, so you can able to find the value of Ix. Okay. So since this current is commonly flowing here in this manner, so whatever the potential here, you can say that this VB and VA are equal, and here you can say VB is what? Basically V naught. The value of VB and V naught is equal. Yes. Okay. So that is equal to VA also. Or you can say VA, that is V naught, or you can say the value of Ix is what? Basically you can say V naught upon 6. It is in milliampere. Here Ix in milliampere. Just keep in mind while solving this type of problems, either resistance in kilo ohm or in a single value. I mean unit must be same. So this you must keep in your mind. So here it is 3K, 6K, 6K, 12K. So yes, we can take it as. So here the value of Ix is what? It is V naught by 6. Okay. So once you know the value of V naught, you will easily know the value of Ix. Now how we will find that value? So if I consider let some potential here, this potential. Okay. So this potential is what? Here V. So I can write here one equation as KCL equation, that is V upon 3K Again it is in K. I am taking the entire current is in milliampere. Okay, so I can directly write it as V upon 3, okay, minus of 4 plus of, now see this Ix current is flowing commonly here. I can write this directly as V upon 12, 6 plus 6, 12, because same current is flowing, and you can say V minus of V naught upon 12, that is equal to 0. Yes. So this is your equation first. Okay, simply it is V by 3, V upon 12, this current is coming towards the node, or V minus V naught upon 12. Okay, now can you say this V upon 12 is basically your Ix? This you can say V upon 12 is your Ix. I already said Ix is in milliampere. This potential upon sum of these two resistance, that is 6 plus 6, that is 12, is what is basically your Ix. Okay, or you can say V naught by 6 is also your Ix. So from here we have to just replace the value of V as 12 Ix and the value of V naught as 6 Ix, and both these value you have to put here and get the answer. So for finding out the answer, just multiplied by 12, so that comes to be how much it is? 4 of V minus of 48 plus of V plus of V minus of V naught is what? 0. So from here you can say that it is 6 of V minus of V naught is equal to 48. Okay, so now what is the value of, here I am solving this, what is the value of V? It is 6 into 12 Ix minus of V naught is 6 Ix, and that is equal to 48. Now just solve it. How much it is? 72 minus 6, that comes to be how much? 66. Ix is 48, so the value of Ix comes to be 48 divided by 66. This is your answer. If you solved it, the value of Ix comes to be how much it is? If you solve this, that comes to be 727.2 microampere. This current is in milliampere. The value of Ix comes to be 727.2 microampere. Okay, so what we actually do in this problem, simply we apply the law of KCL here and finally write this equation, and just by taking the value of V and V naught in terms of Ix, we have just find this answer. Okay. So friends, this is your next problem. In this problem you have to find the value of I naught. Okay. Now as I said, as per the concept of virtual ground, the potential at this node, that is VB, and say this is VA, is equal. So you can say VA and VB is equal, or since this is a node of common potential, so whatever the voltage here is the voltage at this volt. So the value of VB is what here is 0.4, so that is equal to what? It is VA, the first thing. Okay, so we know the value of node VA and VB with the help of concept of virtual ground. Now how you find the value of I naught? How you find? So the value of I naught you can find if you find this voltage. Say this voltage is V naught. So from here you can find this value. Yes, it is applying KCL at this node. Okay, at this node I am applying a KCL. So that comes to be how much? It is 0.4 divided by, that is 10. Again I am taking voltage. This is 10K. Unit is common. and it is 0.4 minus of V naught upon 50, that is equal to what? 0. Yes. So now just by applying, say, multiplied by 50, so that comes to be 542. So it is 2 plus of 0.4, that is equal to V naught. Yes, it's multiplied by 50, so it is 5 and 5 4 20, it comes to be 2. So you can say that the value of V naught is 2.4 volt. This is the value of V naught. Once you know the value of V naught, the value of I naught comes to be how much? It is V naught upon R. And what is R here? This is 20K. So that comes to be 2.4 divided by 20 in K. So the value of I naught comes to be from here is I naught is equal to 1.2 milliampere. Okay, not 1.2. You can say that it is 1.2 into 10 to power minus 4. Okay, or you can say it is 120 microampere. This is the value of I naught. This is your answer. So your value of current I naught is how much? It is 120 microampere. Okay, so this is one type of question we have seen here. Okay, now we'll move with next question. Now friends, this is our next question. In this question you have to find the value of Ix and Iy. Okay, you have to find the value of Ix and Iy. Now please see, this Ix will flow here also. This is also Ixy because no current will enter here. If I consider some voltage V0 here, so this is the voltage V0. So for finding out the value of Ix, first we have to find the value of V0. And once you know the value of V0, you can easily find the value of Iy also. Okay, so if you see the potential at here, since I call it as A and B, so VB will remain here. So the value of VB is basically 8 into V0, applying voltage division rule, 8 plus 2. So that comes to be 0.8 V0. This is the value of VB. Okay, and since VA is equal to VB is equal to 0.8 V0. Okay, now applying this concept here in this question, so from here you can find the value of Ix. Okay, Ix, you can say that first we will find the value of V0 from applying KCL at this node. I am applying KCL at this node, so that comes to be 0.8 V0 minus of 0.5 divided by 5, okay, plus of 0.8 V0 minus of V0 divided by 10. This resistance is 10Q. That is equal to what? It is 0. And you can also say that this is basically your value of Ix. So what we will do, we will first find the value of V0 just by multiplying 10. We'll get it as 1.2. How much it is? 10 to 1.2 V0 minus of 1, and then it is plus of 0.8 V0 minus of V0 is equal to 0. Okay, so that comes to be how much it is? This is 1.2 V0. See, multiplied by 10, 5 to 8 to 16, it is 1.6 V0, sorry. It is 1.6 V0 minus of 1 plus of 0.8 V0 minus of V0. Okay, so that comes to be how much? This comes to be 1.4 V0 is equal to 1. Yes, the value of V0 is equal to 10 by 14, or you can say it is 5 by 7 volts. This is the value of V0. Now once you know the value of V0, I can say the value of Ix, as I mentioned here, this is the value of Ix. So that comes to be minus of 0.2 V0 upon 10. that comes to be minus of 0.2 into V naught is what, 5 upon 7, so that comes to be 70, or you can say it is minus 1 by 70, it is in milliamperes. If you solve this, so that comes to be how much? It is minus of 14.28 microamperes. So this is the value of your Ix. Okay, so this is the value of your Ix. Now once you know the value of Ix, you know the value of V naught, can you find the value of Iy? Yes. How? We'll see. Now for finding this value, I am applying KCL here. Please see. So that comes to be Ix is the current coming towards the node. So it is minus of Ix minus of Iy, current which is coming towards the node, plus of V naught minus of Vb divided by 2, that is what? It is 0. So you can say that the value of Iy is minus of Ix plus of V naught minus of Vb. The value of Vb is 0.8, so that comes to be 0.2 V naught divided by 2. Okay, so that comes to be how much? This is, you can say Iy is equal to minus of Ix, it is 0.1 V naught. Okay, so this is 0.1 V naught. Now just by putting those values, you can get the value of Ix. Okay, Iy. Now we solved it. It is 5 by 7. Just keep in mind it is 5 by 7 volt. So the value of now Iy comes to be, the value of Ix is how much? It is minus minus, so that comes to be 14.28. It is in microampere, plus of 0.1 into V naught. The value of V naught is how much? It is 5 by 7. Okay, the value of V naught is how much? It is 5 by 7. So just keep in mind that the value of Iy is also comes to be in microampere. Why? Because the value of this 0.1 which we are considering here is it was in kilo ohm, hai na? So just keep in your mind. So that comes to be 14.28 plus of, just find this value. So this comes to be 0.5 divided by 7. So it is, you can say in microampere, that comes to be 71.4. It is in microamperes. So that comes to be how much? It is 85.68 microamperes. So this is the value of Iy. This factor which I have solved here, please see, it comes to be 0.5 by 7 and it is in milliamperes. Please keep in mind this 0.5 by 7, this factor is in milliamperes. Okay, but when you solve it finally, the entire value comes to be in microampere. Why? Because we have taken this 14.28 in microampere. Okay, so when you divide it and just convert it into microampere by taking 10 to the power minus 3, so that final value comes to be 85.68 microampere. This is a simple mathematical question. Just when you solve, you will understand. Okay, so this is the value of Iy. So this is your next problem. This problem was asked in GATE 2018. Okay, you have to find the value of V in upon I in. You have to find the value of V in upon I in. This is your next problem. Now how you find the value of V in upon I in? Basically, this OPAMP is ideal in nature, and simply you have to find this value. So please keep in mind, no current will enter here. First, a very important thing. So this I in will enter here. So here is the current is what? It is also I in. Okay. Now can you find this voltage from here Yes, yes, you can find this voltage. So if I say this is A, this is V, so as per concept of virtual ground, VA and VB is equal. So what is the value of VB? The value of VB comes to be how much? It is V0 into R2 upon R1 plus of R2. Okay. So this is the value of VB, and which is equal to what? It is also equal to VA. Now for finding out the value of V in upon I in, basically you have to find the entire equation in terms of V in and I in. Okay. Now if you see, as I said, VA and VB is equal, and V in is the potential which is applied here. So you can say VA is equal to V in. VA is equal to V in. Yes. So from here, V0 into R2 upon R1 plus R2 is equal to V in. Yes. This is our first very important equation. Okay. So now for finding out that value, we can say that VA, or I can write it as, if this voltage is V in minus of V naught upon Z is what? Basically your I in. Can you say? Yes. So now by putting this value in this equation, one can get the answer. So from here I can write it as V in minus of the value of V naught, you just transfer here. So that comes to be V in into R1 plus of R2 divided by R2. Okay. And this whole divided by Z, that is equal to what? Your I in. Okay. Okay, that is equal to what? Here I in. Take V in as common, so V in upon Z into this you find, so that comes to be how much? It is R2 minus of R1 minus of R2 upon of R2 in is equal to I in, or you can say V in upon I in is equal to minus of Z into, so this is your answer, that is V in by I in is equal to minus of Z R2 by R1. This is your answer. Okay, this question was asked in GATE 2018, so you have just tried to understand how we solve it. Okay.